All right, guys, I'm recording, so I would like you to get started. I need you to have the gray unit circle sheet and 2 markers and worksheet 20. I didn't have white, so it was close enough to something the colors would show up on. All right, guys, inverse. Back when we had something like this, we talked about an inverse. We could graph this. And then what would the inverse always look like? Yes, the reflection across the line y equals x. Okay. What else did we do to find an inverse? We did this. We switched the x and y and solved for the y, and that gave us the equation of this green line over there. All right. If we happened to have something like this, the inverse of this was not a function because it did not pass the horizontal line test. Does that sound familiar? This passes the vertical line test, but if we were to reflect it, it would not pass the vertical line test. Okay? So we use the horizontal line test to determine if this function had an inverse that was a function, and the answer for this parabola was no. Then we talked about the fact that you could restrict the domain and it would pass the horizontal line test. We could either pick the left side or the right side of this graph and get rid of it, and then it would pass the horizontal line test. Does that make sense? So if I restricted this domain to 0 to infinity and kept the right-hand side, then it would have an inverse. That sound familiar? Okay. The other thing we need to review before we talk about the trig functions is that whatever the domain was, for example, if I had this goofy thing, whatever the domain was and the range, what happened when I did the inverse of that goofiness? They swap because the x's and y's are changing, so the domain becomes the range and the range became the domain. That makes sense? All right. With all that prior knowledge pulled back to the front of our brain, this is a sine graph. Goes through the origin, everything's good, okay? That sine graph fails the horizontal line test. Does everyone agree? Okay. So we need to restrict it so that it passes the horizontal line test. And we want to restrict it as close to the origin as we can, including all of the y values. So we're going to restrict it from negative pi over 2 to positive pi over 2. Does that make sense? And the y values will be from negative 1 to 1 still? Okay. Then remember when we do an inverse, it reflects across that line y equals x, so it kind of reflects like this. It stretches differently because we've restricted the domain and range, so it ends up looking like this. So what I would like you to do now is go here on your notes, worksheet 20. Draw yourself a little line here showing that you're restricting it from negative pi over 2 to positive pi over 2. And then over here, we're going to draw the inverse sine graph. Now, what's going to happen is it's going to go this way. Yep, that's supposed to be going through 0, 0. I didn't do a very good job. That's not what I meant to move. All right, that's a little bit better. Over here, the restricted what was negative pi over 2 to positive pi over 2? It was x values on this graph, so it was the domain. So on this new graph, that becomes the range. Okay. What was our restricted, or what was the complete range on this graph? Bottom to top was negative 1 to 1. So the domain on this graph is negative 1 to 1. So this graph goes from negative 1, negative pi over 2, to positive 1, positive pi over 2. The book has a lot of questions about graphing these. I didn't assign any to my knowledge, and I'm not going to put it on a test or quiz. You're going to be able to need to identify values of the inverse sign or arc sign, it's called, but you're not going to have to graph this, okay? I'm just trying to explain where the restricted values come from and why. All right. What two quadrants are we talking about if we go from negative pi over 2 to positive pi over 2? Careful. Positive pi over 2, but then we go negative pi over 2, we're going this way, yes? Everybody okay? So we're talking about quadrants 1 and 4. But when we go into quadrant 4, we can't call this pi over 6 or 11 pi over 6. We have to now call it negative pi over 6. So you don't need to use a color. You can use, I think I did I number these for you on your unit circle? We're on the gray unit circle sheet right now. You need to number this one negative pi over 6. When you're doing inverse functions, you're going to call that spot negative pi over 6. What's this one going to be called? Negative pi over 4, negative pi over 3, and negative pi over 2. Then what you need to do is you need to take one of your colors of marker. I'm going to use red. And I'm going to say the arc sign graph, okay, is red on mine. And the arc sign values are only found in these two quadrants. You can just kind of do this along the edge of the circle, because we're going to have another color in quadrant 1 as well. So I don't want you to color the whole quadrant in, or you'll be in trouble. All right. Now, which value is sine? This, it says sine to the negative 1 of x equals, and it's, yes, it's just red. It's just your color coding, okay? It's your little key. Does that make sense now? Yeah, no, that's supposed to read something. I gotcha. All right. The other thing we need to identify, guys, is when we're looking for arc sine, we're looking at which value in the ordered pair. Sine is the x coordinate or the y coordinate, guys. If you don't know this, you're done for the semester, okay? The sine is the y value. So this is the kind of questions you're going to get. I'm going to ask you, what is, not cosine, because we're not doing cosine. Where is the sine 1/2? That's what that question is asking. Where is the sine 1/2? And out of these two quadrants you have colored, you're looking for a sine or a y value of 1/2. And you're going to answer pi over 6. Does everyone understand why it's pi over 6? There is only one right answer. Even though over here there's a sine value of pi at 5 pi over 6 that has 1/2, it is not defined for arc or inverse sine. We can only look in these two quadrants. You also, if it said, where is the sine or the inverse sine of -1, where are you going to answer that? Okay, we're going to answer in radians, and we have to use this Answer, because remember the domain was negative pi over 2 to positive pi over 2. So the place that this occurs at will be at negative pi over 2. We can't call it 3 pi over 2, and we can't call it 270. If you were in degrees, you'd have to call it negative 90. We're just going to always answer in radians. All right, so let's look at these examples real quick. Can you find, I need you to understand this. This notation is exactly equivalent to this notation, or little a, okay? It's just different notation. And apparently they tried to move to a different notation. I don't know how it became that there's two ways to write it, okay? I don't know if they tried to start it, changing it from one to the other, and then books just started including both. I have no idea what happened, but both of these mean the same thing. So this is asking, where is the sine square root of 3 over 2? Okay, I go sine, that's red. I look in quadrant 1 and 4. I look at the y values, and a positive square root of 3 over 2 occurs at? Anybody lost? I'm back here looking at a y value, positive square root of 3 over 2 right there, pi over 3. Okay, this is a question meant to confuse you. This is negative 6.28, right? Negative 2 pi. Okay, picture the sine graph in your head, just a regular sine graph. Does it ever go down to negative 6 if it doesn't have a amplitude or phase shift or anything going on like that? This is not possible. Okay, we answered this one a second ago. Where was the sign negative 1? Arc sine, negative pi over 2. Okay, now I need to explain this. We'll talk more about this when we do equations. Sorry. That actually has infinite answers. Most of you are thinking to yourself, these are the same thing. Okay, they're not, because arc sine or inverse sine is a restricted domain. So the only answer here would be negative pi over 2. This is where all can the sine hit negative 1. It does happen at negative pi over 2. But then it would happen over and over and over again if you're talking about a regular sine graph. Yes? And we'll talk about the way to write those multiple solutions. Just want to clarify. All right, let's go to cosine. What happens when we look at a cosine graph? Do we want to restrict it from negative pi over 2 to positive pi over 2? Is that going to have it pass the horizontal line test? No. Okay, so we could restrict it from negative pi to 0. They usually go with the positive. They do go with the positive. Okay, this restriction right here would get us all the values, and it would pass the horizontal line test. So it's going to be restricted from 0 to pi. On our new one, remember that's going to be the y values when we do the inverse. All right, what were the x values here? Negative 1 to 1, yes. So that's going to be our range over here. All right, I don't draw these very well. Poop. Yeah. That's the shape it's supposed to be, kind of. Okay. This is y equals the arc cosine of x. And the domain is the old restricted range, which was 0 to pi. The range is the old restricted domain, which didn't need to be restricted. I'm sorry, it's the old domain, which was just negative 1 to positive 1. So this ordered, yep, I didn't flip them. Yep, thank you. I'm like, that's not going to work when I go to right ordered pairs. Totally my fault. Okay, over here the x's were 0 to pi. So now those are the y's, or the range values. The y values were -1 to +1, so that's now the domain. So this is -1. Do I have it drawn wrong too? No, it's -1 pi down to +1, 0. Again, you don't have to know the graphs. All right. What's wrong? -1 pi. Okay, better. My graph just stinks. I should have moved. Well, I can't flip those. It won't let me. But they're usually state domain first. All right, guys. So going to your unit circle, I'm going to actually go back to this one. This is what you have so far, yes? What 2 quadrants do we need to do this time? What did we restrict it to? 0 to, we restricted it 0 to pi. So that's these 2 quadrants, yes? Okay. So I'm going to use a different color. And I'm going to show that when I am looking for the inverse cosine, I want to look where it's colored that color. Tangent is going to be the same as one of those, and that's why we don't need a third color. We're going to figure out in a second which one to key as tangent as well. All right, so with this up on the screen, let me ask you a couple quick questions. The inverse cosine of 1/2. Okay, first thing you do, you look and you go, cosine is in quadrants 1 and 2. Second thing you do, it's cosine. So am I looking at the y coordinates anymore? No, I'm looking at the x. Where is the x coordinate 1/2? Pi over 3. Everybody okay? Okay. But when I have a negative, like the inverse cosine of -square root of 3 over 2, when I have a negative, I don't look down in quadrant 4 anymore. I look over in quadrant 2. So where is the inverse cosine? Yes. I answer 5 pi over 6. No renumbering. It's just the answer from quadrant 1 or 2 only. One more. What if I use arc cosine of 0? Where's the x coordinate 0? Pi over 2, right? The only place along there? Everybody all right? Right, the 2 quick examples, or 3 on your paper. I may have already done this one. Did I already do this one? Inverse cosine -square root of 3 over 2. I thought we did, but some people said no. Can you find that one? Because looking at the gray unit circle. Yes. Okay. Yes, we did that one. I was just confused because people said we didn't. I want to make sure everybody got it. Okay. This asks for 2.5. It's nowhere on my unit circle. Okay. And there are some we can actually do that aren't on the unit circle, but for this question, does cosine ever go up to 2.5? Not possible. This one says, where's the cosine -1/2? What angle has a cosine or inverse cosine of -1/2? Everybody okay? All right, last one is tangent. This is what the tangent graph looks like. And sometimes we talk about this part of it as one whole period, but that would be kind of miserable, right? The closest to the origin that we could restrict it and it would pass the horizontal line test would just be these 2 asymptotes right here, yes? All right, so positive pi over 2 to negative, or negative pi over 2 to positive pi over 2 are going to be the new y restriction. So those are going to be the range. Did it have a range restriction here? Did it have an up and down restriction? So it's not going to have over here a left right or a domain restriction, okay? So here, quickly, it's going to look like this. This is negative pi over 2 to positive pi over 2. So the domain is all real numbers, and the range is negative pi over 2 to positive pi over 2 with parentheses, not, these are asymptotes. It never hits those values. For that reason, in a minute, it's going to say this, and there's not going to be an answer to that question. We know the tangent is undefined certain places, but their inverse tangent, where is it undefined? If you look on your unit circle and you put y over x, it's undefined at pi over 2 and negative pi over 2, and these are not included as possible answers here. So this would be, all right, we're going to talk about, because we got to go to the unit circle here. So what do we need to add to this graph? Do we need to add anything? Which quadrants matter for arctangent or inverse tangent? It's positive pi over 2 to negative pi over 2. So it's 1 and 4. So just write this so that you know the key. This doesn't mean that they're equivalent values. It just means they're both the same color, okay? So maybe I shouldn't put an equal sign in here. Just know that you're using the same color for the arctangent and the arcsine. Okay. Tangent is very confusing. Is tangent anywhere on this? Can I just look at this and tell you what the tangent is? No. I have to do a little work. Tangent is what over what? Sine over cosine or y over x. Tangent is tricky. So what I need you to do, guys, you cannot write this on your unit circle, okay? But I'm going to write up here what the tangent would be because I want you to think these all through once. What would tangent be if we started up here? 1 over 0 would be undefined. It can't actually ever equal. You can't do inverse tangent of that, but tangent would be undefined there. All right. What about here at pi over 3? The y over the x would be square root of 3 over 1. Everybody good? Because the denominators would cancel. If you went down here to pi over 4, you'd have square root of 2 over square root of 2, which would be 1. If you went here, you'd have 1 over square root of 3, which would be root 3 over 3. Everybody okay? Y over x, 0 over 1 is 0. What about down here? Y over x, negative 1 over square root of 3. Everybody all right? Negative root 2 over root 2, negative 1. Negative square root of 3 over positive 1. And down here it would be undefined again. Those aren't going to be on your unit circle. So when I ask an arctangent question or inverse tangent question, you're going to take a little longer and have to think and figure out where it is. All right, so let's look at the examples I have for that. 2 examples, okay? First thing, I look at my unit circle, and arctangent tells me I'm looking in these 2 quadrants, yes? Okay, this is negative, so it's got to be in which quadrant? Okay, I'm down here somewhere. There's only 3 ordered pairs down in this quadrant. This one is square root of 3 over 2, negative 1/2. This one is square root of 2 over 2, square root of 2 over 2. And this one down here is 1/2, negative square root of 3 over 2. Thank you. Yep, the second one. Thanks. All right. So down, it was arctangent. I was restricted to quadrants 1 and 4. It's negative, so I'm in quadrant 4. I'm down to these 3. Which one, when I put the y over the x, is going to give me negative square root of 3 over 3? Devin? Okay, this guy right here, because this one, when I put the y over x, I get this, which is equivalent to this. Everybody okay? And so the answer is, oh, I don't know what I wrote there. Negative pi over 6. Okay, we can use this picture for the same thing because, again, it's an inverse tangent, and again, it's negative. Which spot down there, when I put the y over the x, the y over the x, the y over the x, which one's going to give me negative 1? This guy right here, that was supposed to be negative, I don't know. Yes? Okay, so let me do one more. Where's the tangent, or what's the inverse tangent of square root of 3? This time I'm looking in what quadrant? Quadrant 1, because it's an arctangent or an inverse tangent and it's positive. I need the square root of 3 over 1. So where's that ordered pair happening at? All right, ready to try some? Okay. This is on the back. It's actually 20B. This is wrong. Let's see how many we can get done. What time are we out today? Okay, so we got 5 minutes to try these. Yes, there is no advisory, so you're going to go to 6th hour next. I have a pretty one nicely colored for you up here. All right. You should have one in front of you. Arctan of 0. Tan means you have to put the y over the x. 0 over 1 would be 0. So the answer is 0 radians, which we usually don't write radians. Number 2 over here, arc sine, square root of 3 over 2. That means I am looking for an ordered pair that is colored red on mine that has a y value, right? Because it's sine. Devin, do you have an answer for that one too? Arc cosine, square root of 2 over 2. What quadrant am I in? 1? No, because cosine, that's a great question, but remember cosine was restricted to quadrants 1 and 2. Yep. There's none of these that can have more than one answer, so you have to be careful. Yes. Good job. Okay, arctangent negative 1. What quadrant do I have to be in if it's negative? Okay. Which one's going to be, when I put the y over the x, I'm going to come out with negative 1. Right? Because you got to put negative square root of 2 over 2 over positive square root of 2 over 2 would be 1. Remember, tangent is tricky. It's not just the y or the x. You got to put y over x. Number 5, arc sine negative square root of 3 over 2. That's a great question. No, I don't know what that means. It should have one or the other. Shouldn't have both. That's a great question. Yeah. What's wrong? Yeah, I don't, that's just wrong. All right, arc sine of negative 1/2. Who's lost? All right, what's wrong with question 7? It's got a pi in there. What else? It's not an inverse. It's a normal tangent. It is simply asking you to look at any unit circle. Doesn't have to be colored pretty, doesn't have to be restricted, and tell me when I go around in the negative direction 3 pi over 2's, so I'm up at the top, right? What is the tangent at that spot? Well, the ordered pair is 0, 1, so the tangent is undefined. That was not an arctangent or inverse tangent question. It was just thrown in there to trick us. Okay, number 8. This is probably the trickiest one for students because you got to look at those ordered pairs. What quadrant am I in if I have a negative arctangent? Okay, so down here somewhere, yep, I have square root of 3 over 2 and negative 1/2, and down here I have 1/2 and negative square root of 3 over 2. So it's one of those. Which one, when I put the y over the x, is going to give me square root of 3 over 3 after I simplify it? This guy, right? All right. This needs some parentheses. Where's the cosine negative 1/2? Be careful. Cosine is in quadrant 2 negative, right? Okay. Where's the sine negative 2? Never. Undefined, not possible, I think is, I don't know, care, either one. All right, we will pick up here tomorrow. Please, you will get to use that unit circle on the